School of Computer Science at Carnegie Mellon University in 2012. In 2005, he completed his BTech in Computer Science and Engineering from IIT Kharagpur. So Dr. Das's work has received paper awards at ACL and EMNLP conferences. And he also serves as action editor for Tackle and ARR and as senior committee a member at various ACL and machine learning venues. So over to you, Dr. Das.
Thanks a lot, Shondipan, for the introduction. I don't
Okay, so Professor Gurevich, you will have to stop the screen sharing so that Dr. Das can take over.
So I've stopped the screen sharing, right?
But we still see your screen.
Oh, that's interesting. Oh, here.
Okay, thanks. So now, Dr. Das, you can just start sharing. So you are muted, I think. Yeah. I think we can't hear you.
So can you hear me now?
Yes, yes.
So something is happening when I try to share my screen and it's not sharing audio.
Yeah, it has worked.
Can you hear me now?
Yes, yes, yes. And we can also see your screen as well.
Yeah, there was this checkbox selected. Yes, sorry for that technical glitch. And thanks a lot for inviting me to this venue amongst such distinguished speakers. So I'll talk for about maybe 40 minutes and then happy to take questions. Today I'll talk about this area of natural language generation in communicative scenarios. This is work that I've been doing with my colleagues for over 3 years now. Particularly, I'll call out my collaborators, Amy Ankor, David, Elizabeth, Gaurav, Yulia, Hannah, Joshua, Matthew, Mike, Rand, Sebastian, Shashi, Slav, Thibaut, and Vitali. So I'm super grateful for all the work that we're doing together. So there is only one research goal that I'll talk about today. So it's about building trustworthy natural language generation models for communicative scenarios. So I'll start by distinguishing this work from other work that is happening in the generative model space in our machine learning and NLP communities. So communicative scenarios is not the same as open-ended generation from language models, which is quite popular and mainstream. Here we are looking at certain use cases where the system needs to communicate something to the user of use, right? So here it's machine translation where the target is a translation of the source. So this is German to English machine translation. In text summarization, one can see this very, very long news article, which is the source. And the idea is to provide a summary that compresses the text and conveys the most salient aspect of the news article. There could be even more complicated scenarios, like here, for example, this top part of this image is the context. It's a dialogue scenario where a user and a bot are communicating. And there are some grounding documents. So whenever the bot needs to communicate about something about the external world, it needs to rely on a grounding document. So here the target is basically a response to the latest query, but it needs to be respectful of the previous context and also to the grounding document. And I'll go into this a bit more into more detail later on. So all these three scenarios that I talked about are have communicative goals, and they're very different from prompting a language model which provides output. So the other aspect that I will stress on over here is trustworthy. And trustworthy is a vague term. So I'll try to define what we mean by trustworthy. So back in 2014, when researchers developed sequence-to-sequence models, primarily targeting machine translation, it sort of changed our field of generation significantly. It has become sequence-to-sequence models have become de facto modeling framework for generation models, and pre-trained models subsequently like BERT and Pegasus, T5, GPT-3, and all its incarnations have resulted in significant progress. There are lots of advantages of these models. They are end-to-end, so you could train and do inference with ease, unlike models that were more popular before 2014. The target output is extremely fluent. So these models generate extremely fluent language, and the pre-training plus fine-tuning paradigm, which is also widespread in generation tasks, is attractive. You can train a pre-trained model and then fine-tune or adapt it for multiple use cases, and it's pretty easy to develop. However, in spite of these advantages, there are many challenges. So if I take this new summarization task, we get, so this is an output from a state-of-the-art model called Pegasus. We get these summaries where these orange spans in the output are actually hallucinations. So this is a term that I will use quite a bit in this talk. The hallucinations are phrases that are not attributable to sources, to the given source. So the man of the match countermeasures or Santi-Cazor lag, these things just are inconsistent with the source. They're content that are hallucinated by the model. And this poses significant challenges and risks for in terms of using these large generation models in practice. I'll go into a little bit more detail about some other use cases. So this is taken from the Wikibio dataset from 2016. The Wikibio dataset's goal was to take an info box in Wikipedia. Like here, you can see the bio of Frank Lino. And then the idea is to generate one sentence about the person. So the info box is there, and the target over here is a biography sentence. Models trained on such data hallucinate significantly. And here you can see that this criminal defense attorney phrase is just not supported by the source. And this happens significantly in this scenario as well, in this data set as well. So what are some causes of hallucinations? There are many, and I will try to highlight 3 or 4 of these things. So this blue span over here is actually noise in training data. So the training data itself is very noisy. So when the way Wikibio was constructed, for example, was to automatically pair up info boxes and associated sentences that appear beside the info boxes in the Wikipedia article. There was no cleaning up of the text, and hence there is a lot of content in these targets that are not supported by the source. So training data noise is like one of the first reasons why models hallucinate at inference time. The second is poor evaluation metrics. So here, basically on the right, I'm showing 4 targets for one info box. The first one is a human reference, which is the data coming from the actual data set. And then 3 candidates here are coming from 3 different models. And we see that the candidate 1 basically hallucinates content. Basically, it has this phrase in the California band Grateful Dead, which is not supported by the source. And the third candidate is actually pretty good because it uses the term, the phrase from Seattle, Washington, which is inferred, can be inferred from the info box. But if we use evaluation metrics like BLUE, which are very popular in the community, we see that it gives the highest score to the candidate that is the worst because it has this hallucinated phrase, which is not attributable to the source. So basically, evaluation metrics gives us wrong signals when we use them to select models and so on. So poor evaluation metrics is the second category of problems that we have in this area. And the last one is lack of control in models. So here I'm just showing again the sequence-to-sequence model. Here it's a conditional model where we're trying to model the probability of y sub t, which is the output at a particular time step t, given the history of generating the previous y's, and x is that, which is the source. So these sequence-to-sequence models and decoding algorithms do not control for hallucinations. They do not explicitly model the type of text that should be generated for that particular communicative scenario. And the training objective functions, which I will not talk about in this talk, are also problematic. The objective functions do not optimize for the communicative goals of a particular use case. They just optimize for maximum likelihood. So there is a lot of room to do research in that area as well. So so that was my motivation to why do we need to work in this area and try to make our systems more trustworthy, more controllable. So the talk is divided into two sections, evaluation and benchmarking and controllable models. We have written close to a dozen papers in this area, which are, I should say, just selected from a pool of large number of papers that we've been writing. And I'll talk about a subset of this. When we started working in this area 3 years back, we realized that the area that has the most amount of room to make it better is the evaluation area. So we focused a lot on evaluation. So bulk of the talk will be about evaluation and benchmarking. And at the end, I'll talk about a couple of methods that make models more controllable. So let's start with evaluation and benchmarking. So I talked about the Wikibio data set just now, which was gathered automatically by pairing up info boxes and biography sentences at the top of the Wikipedia page. And there is a ton of noise in that data set. So the first thing we did was to come up with some reusable human annotation techniques to create clean data sets. And we created this data set called ToTTo, which has about 120,000 training examples. And what it does is it pairs up metadata about tables in Wikipedia, like the table title, the section title in which the table appears, the table description, and the table itself with highlighted cells, the yellow ones are the cells that are highlighted over here. And then on the on the right, we have a target that captures the information in the source, including the highlighted cells. So there is a lot going on over here. The red boxes over here show how the target is related to the source. So here you see the alignment between the table title and the section title with parts of the target. You see that these 11 years have been summarized as 11 on the right. So there's a lot of inference that one needs to do here. Then we have things like 8,000 rushing yards, which can be inferred from parts of the cells in the table. And then there are other spans in the target that needs to understand the structure of the table. So this data set, there is to build models on top of this, they need to do a lot of work to get them to actually produce the desired targets. So how did we, so I want to get into a little bit about how we did data collection, because this kind of approach, we believe, can generalize to a lot of existing data that can be cleaned up to create data sets. So for example, here what we do is we get tables from Wikipedia. We use heuristics such as word overlap or hyperlinks to find sentences that may be related to the table. So we pair these things up. After that, we see that these heuristically collected sentences are too noisy, like we saw in the WikiBio dataset. And these blue spans are things that cannot be inferred from the table. So what we do is we asked human annotators to look at the original noisy sentence here on the left. We asked them to delete content that cannot be inferred from the table. We also asked them to highlight cells in the table that support the sentence. And then we asked them to decontextualize the sentence, which is basically there are pronouns after this deletion step that need to be fully specified to make the sentence stand alone. And then finally, there is a grammar fixing step that fixes the grammaticality of the sentence. And this process is quite efficient, and we were able to scale this up to create 100,000 plus table text pairs. We also are able to measure annotation agreement, and at various stages of the annotation process, we see between 70 to 80% blue 4, which is a pretty high degree of n-gram overlap metrics. So so that's the basic summary of how the data set was created. The novelty here is that we are doing controlled generation. Set of highlighted cells gives guidance as to what to generate. Previous data sets in data to text generation like WikiBio and RotoWire contained significant noise in targets. We were able to create a large data set via this process. We have a leaderboard in place, and we are getting submissions over the last year plus with improving automatic metrics. We also see from our original paper that human evaluation numbers for Oracle predictions are above 90 for both fluency and faithfulness. Faithfulness is a term that I will use throughout the paper. It means whether throughout the talk, which means whether the generated target is faithful to the source, so that there are no hallucinations. Now, BERT to BERT, which is not really a state of the art any longer, it only has a 76% faithfulness number on this task. So there is a lot of room to improve models on this particular benchmark. Now I will switch gears a little bit. Like we are only, so at Google, we have, it's a big organization, but we can't capture the entire field, right? So in the past year or so, we have started collaborating with the wider natural language generation community. And one of my team members, Sebastian German, is leading this work. And this is with 50 plus collaborators across industry and academia. We've started working on this GEM benchmark, which is a living benchmark / workshop that is happening at various ACL venues. So what is GEM? GEM tries to organize natural language generation evaluation. It is, because it's challenging, it's fragmented, it's constantly evolving. On the right, there are these 4 dimensions: improving data, improving models, improving automatic metrics, and improving consistency in human evaluation. All of these areas need improvement. So the idea is to build models. Models will be submitted by people, including ourselves. There will be an evaluation infrastructure that builds, improves, and expands over time to create NLG benchmarking that is robust and future-proof. So in each of the dimensions, data, automatic metrics, and human evaluation, there are many dimensions to develop new things, improve current state of the art, and collect new data, new metrics, and new human evaluation techniques, both at eval time and also at training time. So the way GEM worked was there was a lot of deliberation that resulted in the selection of, I think, 13 data sets across 4 generation tasks like dialogue, summarization, simplification, and surface realization across 18 languages, the varied sizes of training data from 5,000 to 500,000, and various input formats were used. The ToTTo work that I just mentioned is included in this set of data sets. So the other thing that we have done here is a bit different from other benchmarks like glue and superglue, which are used in the NLP community for various benchmarking purposes. We don't want to say things like system foo performs the best. We say that system foo, we add some nuance and say that it leads to consistent performance increases in bar type metrics on challenges that measure bars while maintaining equal performance on most metrics of type quotes. So this is like a nuanced statement to actually tease apart what kind of phenomena, what kind of subset of phenomena a particular system is good at. So we rely on multiple experiments, we look at specific claims, we look at many metrics, and we also acknowledge limitations. So this is sort of a complex table that came out of the first run of GEM, and we see that on the data sets are shown vertically, and horizontally you see what models work for those data sets. So it's a pretty complicated picture. There is no clear best model, and for English tasks, we see that there is a spread across various models, various incarnations of the T5 model. For non-English tasks, we see, again, things like MT5, which are multilingual versions of T5 that are pretty good. For 5 tasks, they're pretty good, but there is, again, a spread. There is no thing like X model is the best across all tasks, given how this is structured. This is the last slide about GEM. So we acknowledge the pitfalls of leaderboards. Basically, leaderboards encourage hill climbing and it optimizes blind optimization. It doesn't consider factors like size and efficiency, and that can confound findings. There are model shortcuts also, where models are actually not using the desirable properties of the task to make the right predictions. And finally, we also see this phenomenon of benchmarks getting quickly obsolete or solved due to the way they are constructed. So we have addressed all of these things in various capacities in GEM. And I encourage you to take a look at the website, which is gem-benchmark.com. I will flash one slide about this new work that is not public yet, but will be in the next few days. So we are writing a paper called Measuring Attribution for Generation Models. So attribution is a term that we are introducing in this paper, which tries to assess whether an utterance generated by a system is attributable to some source. So what it is trying to do is that big models that generate text sometimes generate content about the external world that are not supported or are attributable to some source evidence. So for example, on the right over here, it's a conversational question answering scenario. I'm showing 2 queries on the left here. The output here should basically be supported by this passage, and we ask human annotators to check whether this kind of attribution is there for a system utterance, and we establish that this task can be done efficiently by human annotators. So this is like a short preview of the work. The paper should be available in the next few days. So this is basically the end of the human evaluation and benchmarking part of my talk. I'll talk a little bit about automatic metrics because that's another area which we have been focusing on. And there is a lot of traction in this area across the whole field. Basically, automatic metrics are a bottleneck to progress. Low correlation with human judgments for metrics, such as BLUE for machine translation primarily, Rouge for summarization, and Meteor again for machine translation, in various regimes of data and quality of models, these metrics do not correlate with human judgment. So that causes a huge problem because we cannot hill climb and do model selection based on these metrics. So here is like a anecdotal evidence of what goes on, right? So this is from the data to text generation area. I'm showing some predictions here and some references here on the second column. So what we see is that in the ideal scenarios, the word overlap between a bad prediction and a reference is low. But we also see in the second row over here that there are incorrect predictions, but there is a very high overlap with the reference. So here we see 8 Grand Prix races and 6 classes. Actually, we see in the reference there are 6 Grand Prix races and in 5 classes, right? So rest of the content, there's a lot of overlap, but these crucial areas, there is incorrect prediction on the left. So metrics like Blue and Rouge that rely on n-grams fail to identify these issues. Similarly, sometimes references have more information, which could be crucial information that the prediction doesn't have, and the metrics are unable to handle this. So what do we do, right? So we started with one well-studied task in this case, which is machine translation, and we investigated the idea of learned metrics. So what are learned metrics? Each natural language generation use case has their own task-specific success criteria that are usually evaluated by human annotators. And they can be captured, in our opinion, only by learned metrics. So a naive learned metric at the time was to take BERT and then train to predict the human ratings by just fine-tuning on human ratings data. So let's say that humans evaluate the output of a generation system, and we want to emulate that. We take BERT, we train on human ratings data, and we get a learned metric. The problem is that this is brittle because it may require lots of fine-tuning data for every new data set or task. There are other problems like distributional shifts and the gameability of learned metrics, where systems may want to optimize for learned metrics and then overfit in a particular domain. So what we did was we proposed this metric called BLERT that does an additional pre-training step based on synthetic data, and it makes our learned metric a lot more robust to train test skew and enables fast adaptation to other domains. And we get state-of-the-art results on machine translation evaluation, and also one other structured to text task called WebNLG. So here are some results on the y-axis. You see Pearson correlation of BLERT and other learned metrics with human ratings. And we see that things like Blue that have very low correlation are on the left, but as we go towards the right, BERT score was another metric that was published a few years back, but was not learned, but utilized BERT embeddings. Our proposal here with BLERT are significantly better than any other previous metrics. We see similar trends. There's a lot of numbers over here, but the summary is that on WebNLG, which is a structure input to text generation task, we get very strong results as well using BLERT. We have significantly improved our original work on BLERT that was published in 2022. Basically, running BLERT, which is based on BERT, is very difficult on low resources because how large the models are. So we used model distillation to take a teacher BLERT model and distill it into a much smaller student BLERT model that can be used widely in scenarios where there is low compute resources available. So here are some rough numbers. We see that we can distill a very large model close to 600 million parameters here, the teacher row over here, to a much smaller model. There are more smaller models in our paper here, that was published in EMLP this year. But basically, we reach the performance of the teacher almost using a much smaller model that can be used widely. We also, the original BLERT work was published on English targets only, but this approach, one could train one model for a variety of language pairs that can be used to automatically evaluate machine translation. So I should also highlight that the community is moving towards learned metrics. This work called COMET, which came out of Unbabel, is very related. Perhaps it's even better in some scenarios, which also uses learned metrics for machine translation. We are also seeing other learned metrics work emerging for tasks like summarization and so on. So the field is moving towards learned metrics for automatically evaluating generated text. So what are some directions? I'll talk about future work at the end, but these are some immediate outlook items for learned metrics. So we would like to do two things here. One is the GEM benchmark that I mentioned doesn't really utilize learned metrics that widely. So we are trying to see if robust learned metrics can play a large role within the GEM benchmark. So that's one piece of work that's in the near-term horizon. We are also seeing a lot of work in the community to use BLERT to optimize and do better inference in generation models. Here are two papers, not from our group, but one from Korea on reinforcement learning optimizing towards BLERT. And then there is another work from the Google Translate research team on better decoding using BLERT. So we are seeing that this kind of learned metrics are being adopted to great efficacy by others in the community. Okay, so that was the end of my evaluation and benchmarking section of my talk. And the remainder, maybe the 10 minutes after this, I'll talk about modeling research. So there are two pieces of work that I'll talk about, although we have other prior work in this area. But these two papers that we published in 2021 are, I would say, have ushered in a new era of models in this space, and there's a lot of room to grow beyond these two approaches. The first is controllable response generation for knowledge-grounded dialogue, a task that I mentioned earlier in the talk. So informative dialogue agents could be quite useful, we think, where a user can ask things like, what foods can I feed my dog? And the bot may say, carrots and apples are safe. But we also think that when a bot says something like this about the real world, it should be supported by documents, some documents that we trust. Or in other words, the responses need to be attributable to supporting documents. Things like most love chocolate, I eat apples with my dog every day, all these things that a typical language model may generate may not be supported by documents, and that's not super useful in our opinion. Now, I talked about this kind of a source target scenario in the first few slides of my talk, where in the source, so typically all the tasks that I talked about have a source and target setup, right? So the target is generated conditioned on the source. In this scenario, the source is pretty complicated. It has some context, which is a user and a bot interaction. And then the last turn is the last user query. So for here, it is basically if the user says, I visit animal shelters fairly often, the bot says, there's a really nice no-kill shelter by my house that I volunteer at on Wednesdays. The user says, I see. Is a no-kill shelter different from a regular animal shelter? And we, the system, has to generate a target that says, yes, a no-kill shelter. Yes, a no-kill shelter is an animal shelter that does not kill healthy or treatable animals even while the shelter is full. That's the target. But it has to be relevant to the context, but also to a grounding document that has to support this target. The grounding document needs to be the basis on which this target is generated, and that document is also part of the source. So that's the setup of this task. So in this work, we are trying to fuse earlier work on general knowledge grounded dialogue and also hallucinations in text generation, which we talked about in the evaluation section. So we use a lot of evaluation measures in this work, like the response has to be objective. First person responses about real world scenarios is a bit odd. The response content has to be derived from the evidence, that grounding document aspect that I talked about. And also the response should be inferable from the evidence. So they should be entailed or supported by the grounding document. We use this data set called Wizard of Wikipedia that the Facebook research team released a few years back. It's relatively large. Some terms are knowledge grounded, some terms are not. Actually, in this data set, 44% are first person responses, which we don't think should be used for responses that need to be grounded. The lexical precision with grounding documents are not that high, and some of the responses are also non-entailing. So we need to put some control mechanism in our generation system so that the grounding aspect works as we like it to work. So how does this work? Normally, it's a sequence to sequence model, like a T5 model. So the T5 model uses a conversation history, a retrieved evidence, which is the grounding document, and it provides a response. In addition to the conversation history and the retrieved evidence, we add these control codes that help us ground the model and provide a response that is desirable. And I'll get into that a little bit. So basically, we also have a decoding type resampling step, but it is less important than the control codes. So what we do is that at training time, we add style information about the goal response as extra inputs. We hope the model learns to use style information to better predict goal responses. And then at generation or inference time, we hard code style inputs to informative style. So for example, if in the training data we have a response like response target like Jerry Garcia passed away in 1995, we use these three features: lexical precision with respect to the evidence in the grounding document. We use a feature called contains first person. Here it does not. And an NLI prediction that determines whether the response is entailed by the grounding document. And these three things form a control token sequence, like high lexical precision, no first person, and yes, it is entailed by the grounding document. And that control tag sequence is added to the input to T5 and alongside the conversational history and the grounded document sequence. And at decoding time, we resample to ensure that the responses also has high lexical precision, no first person, and whether or not it is entailed by the grounding document. This aspect is sort of a hard constraint at decoding time that also helps. So what do we see? On automatic metrics, which are whether or not the response is first person, whether there is high lexical precision, and whether the response is entailed by the grounding document, we are much better than the prior art here based on this control level generation technique. And on human evaluations, what we do is we take model output and we take 100 examples per model and ask 3 human raters to judge whether the response is relevant to the conversational history, whether it is faithful or fully supported by the grounding document, and whether it is objective. And we again see that from relevance perspective, all models and baselines are great, but in terms of objectivity and faithfulness, this approach is much better than the prior state of the art. So that ended the knowledge grounded dialogue response generation work. And I'll end by talking a little bit about controllable entity-based planning for summarization. It is very similar in nature, but I think we are going towards a more general framework of controllable models that capture the communicative goals of a particular task. So what happens, I showed a slide like this in the past. In case of, say, news-based summarization, there's a news article and a human written summary, which is our target. So what happens is when we use a state-of-the-art generation model to train a summarization system, this is Pegasus, we see that it produces these hallucinated phrases that are not supported by the source. So what can we do to help? So we break the task from source to target, sequence to sequence generation, to provide an intermediate target, which is a plan. So this is not new. There's a lot of work happening like this in the community. But here the interesting aspect is that we use this entity-based plan as the intermediate target because entities are really important in the news domain. So you see on the left, there is a source news article, which I've compressed from that large blob of text. And then there is an entity plan. So you see these three vertical bars. They mark sentence boundaries. And within each sentence boundary, there are these chains of entities, okay? And the model has to produce this intermediate target first, and then the final target summary is produced by conditioning on the source and the entity plan. And you can see that in this particular case, which has been cherry-picked, but the entities appear in sequence, and we do not see any hallucinations, unlike the vanilla model that I showed in the previous slide. And we call this model Frost. Now, what are some advantages of this entity plan? Basically, it can firstly be fully automatically generated by the decoder, but it can also be semi-automatically generated by correcting hallucinated entities. So let's say that the decoder generated the plan as an intermediate target, and there are some wrong entities. We can go back to the source and see if there are wrong entities, and then we avoid generating the wrong plan. And then based on the correct set of entity chains, we generate the final target, and that's really useful. We will see in some results. The entity plan can also be manually controlled, right? So if there is a human in the loop, they can sit and edit the entity plan and then generate the target after that. And then finally, the entity plans can be sampled in such a way that there is like a diverse chain of entities, and you can generate diverse summaries by tweaking the plan. Okay. So I'm running out of time, so I'll go a bit quickly. Basically, Frost, this method can also be used to pre-train. I encourage you to read the paper. I don't want to get into details. You can create pre-training objectives also in addition to doing inference. And we see that compared to models like Pegasus and BART and MAS, which were state of the art when this paper was published earlier, we see improvements in automatic metrics, but on human evaluations, on faithfulness and overall quality of summary, we see gains over Pegasus, which is another state of the art model. So basically, this was my overall summary slide. I talked about all this work on evaluation and benchmarking and controllable models. We showed that methods for standardization of data creation and human evaluation for NLG problems is super important to make progress, and we provided some ideas here like ToTTo, which is this data set, the collaborative effort on GEM, and the attribution work AIS, which will be published or made public soon. We talked about learned metrics, BLERT, and other related work. And finally, we talked about two controllable model instances, for dialogue response generation and summarization. Yeah, so in the future, we plan to work more on learned metrics, and also try to have a tighter loop between models, automatic metrics, and human intervention. We want to build more robust human evaluation strategies and make planning-based generation a standard for all kinds of generation tasks. Thank you.
Thanks, Dr. Das, for this nice presentation. So we already have some questions from the audience. So let me pick them up. So the first question is, if a certain entity pops up in the summary which is closely related to an entity in the original document through some external knowledge base, that means this relation perhaps comes from prior pre-training, would that be considered as hallucination?
It's a very good question. In my opinion, yes. The type of, I mean, there is no clear answer to this question because it would depend on the use case. But for new summarization, in my opinion, if there is an entity that is identical and can be resolved via knowledge graph, sure, that is fine, right? So entity spans may look different, but they may resolve to the same entity. But if it's a different entity ID, then I think there is a problem, and I would consider it to be a hallucination.
Yeah. Okay, so there is another question. Entailment scores using some pre-trained model has proven to be a metric well correlated with human evaluation of faithfulness for controlled short text generation. Is there a similar entailment-based metric for long text case? And if so, how good is it?
Very good question. There are some papers like Quest Eval. I think I would recommend Googling for Quest Eval, which is, I think, one of the metrics that I've seen recently for summarization evaluation automatically. But I think it's pretty hard to build document level summary evaluation metrics because documents are very long and so on. So it's a very interesting area to work on. And the only thing I'm aware of, there may be more work, is this Quest Eval paper.
Okay, so there is another question. In controllable entity-based summarization for evaluation, they are finding any overlapping of entities in original documents with predicted text or golden summary with predicted summary.
I'm trying to understand this question. So are you asking whether, yes, so there are entity-based evaluations, which I didn't show in my talk. So there are two types of evaluations that one could do. So one is whether the overall summary captures the salient aspects of the source document, whether the summary is faithful to the source document. I can also ask whether the entities in the summary are wrong compared to the source document. If that's the question, yes, there are evaluations of that kind that we do.
Okay, any questions from the panelists? Yeah, Professor Ganguly, I guess you have a question?
No, it's fine. I think it's a
okay.
great talk.
Okay.
It's a great talk. Thank you, Dipanjan, for this talk. Yeah.
No problem.
Okay, so if there is no more questions, so I guess we come to the end of this session. So let's thank all the speakers once more for their great talks. I will now hand it over to Professor Dasgupta, who will then close IndoML 2021.
Okay, thank you. Thank you. Thank you, Professor Dipanjan, and thank you, Sandeepan. So just so, I mean, this should not require a set of slides, but just so I don't forget anybody's names, I just put down a bunch of things in a slide. So let me just share my screen. So this is visible, I assume.
Yes, we can see your screen.
So first of all, yeah. So of course, this is what we've been doing. We started off with an ambitious plan. I mean, initiated by people at IIT Gandhinagar and IIT Kharagpur. But of course, we've collected volunteers from who are now spanning across the globe, from RWTH Aachen, from University of Warwick, Google, DCS Research, everywhere else. We're very proud of that. And first of all, thanks to all our amazing speakers, right? Because this being an online event, we've been very ambitious, and we have really reached out to the top of the line in all the I mean, wherever we could find, right, across the globe, right? And all of you have said yes. You've devoted a lot of time to doing technical testing with us, to even attending all the other sessions, just to sort of get a feel of the conference, to sort of attend, I mean, giving amazing talks, which has opened their eyes to various aspects of data, in terms of in terms of languages, in terms of doing social good, in terms of different aspects of fairness. I mean, amazing talks. Thank you so much. Right, and also answering the questions. Right, all of you have been patiently answered these very interesting questions that were raised with the audience. So thank you again for that. Right, and of course, so they have ranged from IIT Delhi to Michael Imperial College of Bronstein, to Dipanjan, to Irina. I mean, everywhere. So thank you again. A very special thanks to our sponsors. ACM India is our title sponsor, so thank you. And we have our Datathon sponsors: Microsoft, Google, IBM, and ShareChat. And all four of them have also contributed to the Datathon, to the actual challenges. But this is for the sponsorship specifically. And we have worked with, well, I mean, for each of them, they patiently waited with us while we worked through the agreements, through our sort of officials. We sent them the invoices. There were delays, but they were all very patient. So thank you. Right. Thanks, of course, to the audience. Right. This is what we have been doing this for. Right. And the audience, we had over 2,000 registrations. We had a pretty significant presence. Right. I mean, online events always have a slightly lesser presence than expected, but this really met our expectations. Right. And more importantly, the people who were present, they were extremely engaged. Right. I've been amazed by the kind of questions, and a number of speakers have commented on that the questions are very thoughtful, right? And a lot of them were sort of very thoughtful questions that often led to sort of directions of future research, highlights directions of future research, and thank you for that. Right. This year, on top of having the talks, we had this very ambitious sort of plan of organizing a month-long datathon, right? And we had perhaps jumped into this without sort of thinking how much effort it is, right? And then we contacted a bunch of companies, and Microsoft, contributed a data set, the glucose NLI knowledge. IIT Kharagpur faculty and as well as the students prepared the IndoAri and the Emmanuel data sets. ShareChat contributed the multilingual abuse detection data set. And the IBM research has contributed the COVID-19 data set, on which the challenge has started, right? But that has not yet ended, right? That's going to go on for some more time. So thanks to all these companies as well as IIT Kharagpur faculty and students for these data sets. But none of this would really have been possible without these four individuals, right? Because say us senior, the gray hat organizers, we had really no idea about how much work it is, right? Together, these four people, Vidisha, Shomok, Jayesh, and Sandeepan, they had amazing coordination. They put in a huge number of hours in defining a challenge, getting it labeled. I'll come to the labelers in sort of doing the coordination of the labeling, putting up the data, sort of answering the discussion forum questions. And there were a lot of feedback from the participants, and things were changed on the go. things are changed, and some policies were changed on the go, because a lot of participants sort of said that we should do it this way, and that felt correct to us. That feedback felt correct to us. So thanks to all 4 of you. All of you are extremely busy in your daily lives, but thanks for sharing your time. And this is our amazing team of dedicated volunteers from IIT Kharagpur, from LTI, and from IIT Gandhinagar. So together, if I'm not very mistaken, together there's probably 100 hours of labeling work that they have put in preparing these data sets. Right? So thank you. I mean, again, without you guys, the Datathon challenge would not have been possible. And these data sets are going to be there. So thank you. And we had 400 teams who participated in Datathon, right? A large number of them did submit results, and we have announced the winners, right? So thank you for the Datathon participants. We would like to do this going forward. So any feedback that you have, we would like to hear from you, what we could change, what was the level of the Datathon, whether it should be harder, whether it should be easier. I mean, any kind of preparatory material that we should really have pointed you to. So any feedback that you have, we would really like to hear from you. So please feel free to reach out to us. So thanks to Vivek and Amina for sort of making all the publicity possible. So I hope, yeah, no, I'm not going to say anything. I hope there are sort of posters of them saying that, okay, that these are the people who really are sort of reaching out through our Gmail and through our other mail servers. Who's the culprit of sending out all these emails? But thank you both of you for coordinating, and thank you Raj Sharma for giving us all the different sort of sources, all the different avenues to help with the publicity. Our backend team with the web design, the IT design, and the design and the design support, right? So Raviraj helped us with in designing the web, our website, right? Sudeep helped us with figuring out various times when we would get blocked by Gmail for sending out too many emails in one day, right? And Gaurav, we would reach out to him at sort of late hours, saying that we need the certificate tomorrow morning, and he would do it for us on time, right? So thanks to all of them. And finally, we hope to see you all again in 2022. And our fervent hope is that we're going to do it an in-person meeting, right? But whatever happens, right? We are going to have this again in 2022. Thanks to all of you, right? And have a nice vacation, have a nice break. And that's all. So let me just stop my share.
Sure. Thanks, everybody. Yeah.
If I missed anybody, please feel free to sort of interject, leave out anybody's names that I might have missed.
I think you missed Sachin. Sachin.
Yes.
He was a resource person for all kind of this registration thing, like sending panelist links to all the people.
Cool.
Anyway, see all of you soon.
All right then, take care.
Yeah. Let us have a meeting maybe after 15 days or some days. And okay, bye. It was amazing working with all of you. Thank you for working together here.
Thank you.
Bye.